In the last video, I explained how we used stage 2 of the non-oxidative branch of the pentose-phosphate pathway to obtain 2 molecules of xylulose 5-phosphate and 1 molecule of ribose 5-phosphate. In stage 3 of the non-oxidative branch of the pentose-phosphate pathway, we will transform these sugars into 2 molecules of fructose 6-phosphate and 1 molecule of glyceraldehyde 3-phosphate. And hopefully those molecules sound familiar, maybe more so than the others we've been talking about in this pathway. So to summarize stage 3, there will be 3 separate reactions that constitute stage 3. In the first reaction, we will take one of those 5 carbon sugars and react it with another one of those 5 carbon sugars to obtain a 7 carbon sugar and a 3 carbon sugar in reaction 6. In reaction 7, we will take those 2 products from reaction 6 and do a carbon shuffling reaction to get 6 carbon sugar and a 4 carbon sugar. Then we will take that 4 carbon sugar and a third molecule, a third 5 carbon sugar that we obtained from stage 2 and obtain a 6 carbon sugar and a 3 carbon sugar. So again, to summarize, the 3 5 carbon sugars that we obtained in the non-oxidative branch of the pentose-phosphate pathway in stage 2 will be in stage 3 transformed into 2 6 carbon sugars and 1 3 carbon sugar. Our textbook has this representation of how the carbon shuffling reactions occur. I think it might make more sense if we go over each one of those reactions in turn, and then I show you how these diagrams work. So first, let's look at what in this figure is diagrammed reaction 6. We're going to take 2 5 carbon sugars and use a transketolase enzyme to shuffle the carbons so that we get a 7 carbon sugar and a 3 carbon sugar. So let's look at this reaction right here. But before we do, let's note that in these 3 reactions, all of them will constitute a reaction in which we have 2 sugars, one of which is a ketose and one of which is an aldose. And in the reaction, we will get another ketose and another aldose. The sugar that was the ketose will become an aldose, and the sugar that was the aldose will become the ketose. We should also note something about transketolase enzymes. How do these enzymes work? Well, what they do is they transfer 2 carbons at a time. And in our reaction, we have the ketose will serve as the donor of those 2 carbons, and the aldose will serve as the acceptor. And the way I remember that is that aldose and acceptor both begin with A. And when you're drawing the structures, you should note that whenever you see a ketose in these pathways, that at the carbon number 3, the OH always points left. So I've labeled this step 1. The other figure I just showed you had this labeled as reaction 6. But in any case, this is the non-oxidative branch of the pentose-phosphate pathway, stage 3. And there are 3 steps. This is the first one. In this reaction, we have ribose 5-phosphate and xylulose 5-phosphate will be transformed to glyceraldehyde 3-phosphate and acetoheptulose 7-phosphate. What's happening here is that the enzyme is the transketolase, and as we just noted, 2 carbons are going to be transferred. The ketose is going to be the donor, and the aldose is going to be the acceptor. So that means if 1 carbon sugar donates 2 carbons to the other one, we are left with a 3 carbon sugar and a 7 carbon sugar. Here are the structures, and here's the diagram repeated. So here we have on top, this is the xylulose 5-phosphate that we obtained as a product in stage 2 of the pentose-phosphate pathway. So here's the ketose up here, shown in green, and this is the aldose, that's the ribose 5-phosphate, shown in black. The enzyme is a transketolase, and as shown here, we are going to carry out a reaction in which the ketose, and that's this sugar up here, donates 2 carbons to the aldose. When that happens, this 5 carbon sugar now accepts those 2 carbons and now has 7 carbons. This 5 carbon sugar, having lost its 2 carbons, now has 3. When we're drawing the structure, the ketose becomes an aldose. It's now a 3-carbon aldose. And this 5-carbon sugar that's accepted the 2 carbons is now a 7-carbon ketose. So I have just described this reaction right here. I took 2 5-carbon sugars, a xylulose 5-phosphate that was a ketose, a ribose 5-phosphate that was an aldose, transferred 2 carbons to get acetoheptulose 7-phosphate and glyceraldehyde 3-phosphate. Let's look at the second reaction in stage 3. Here we will take these 2 products and we will react them, but this time the enzyme is an aldolase. And there are some similarities, but there's one difference in that the transaldolase will transfer 3 carbons at a time. The ketose is still the donor and the aldose is still the acceptor. And when you're drawing structures on the ketose, the OH on the carbon number 3 points to the left. So the products of that first step were glyceraldehyde 3-phosphate and acetoheptulose 7-phosphate. We will now carry out a reaction in which the ketose, which is the acetoheptulose 7-phosphate, is the donor, and the aldose, the glyceraldehyde 3-phosphate, is the acceptor. But this time we're going to transfer 3 carbons. So I'm going to transfer 3 carbons over here. Now this 3-carbon sugar becomes a 6-carbon sugar, and the 7-carbon sugar becomes a 4-carbon sugar. So here are the reactions. I'm going to let you draw the products, but I'll again remind you that we're starting out with a 3-carbon sugar and a 7-carbon sugar. The 3-carbon sugar is the aldose. The 7-carbon sugar is the ketose. A transaldolase carries out a reaction so that the 3 carbons are donated from the ketose and they will be accepted by the aldose. So what you should do now is you should pause this video and draw the structures of the products. Hopefully you ended up with something that looks like this. Again, a transaldolase enzyme carries out a reaction in which the ketose donates 3 carbons to an aldose. That means that the 7-carbon sugar has 4 carbons remaining. It was a ketose, now it's an aldose. This sugar right here was a 3-carbon sugar. It accepted these 3 carbons, so now it is a 6-carbon sugar. It was an aldose, it becomes a ketose. So you know how to draw the structure of a ketose. The ketoses always have carbon number 1 is CH2OH. Carbon number 2 is this ketone group right here. Carbon number 3, well, the OH points left, and that's how these reactions work. And here you just retain the configuration from the 3-carbon sugar. So I just described the second reaction. These are the 3 reactions in the non-oxidative branch, stage 3 of the pentose phosphate pathway. Let's look at the last reaction. That also will be catalyzed by a transketolase. I'm going to use one of my products, the 4-carbon sugar that I got from this reaction right here, and I'm going to use that as a reactant. And now I'm going to bring in that third 5-carbon sugar that I got as a product of stage 2 of the non-oxidative branch. So that was a ketose, the xylulose 5-phosphate. And there's the product of that step 2, which was the erythrose 4-phosphate. A transketolase reaction, if you remember, involves the transfer of 2 carbons from the ketose to the aldose. And this was the 6-carbon sugar that we got from step 2, so this remains unchanged. All right, I've given you the structures of the reactants, and hopefully you can draw the products. Again, it's a transketolase, so we have a ketose and an aldose. We have a 5-carbon ketose and a 4-carbon aldose. A transketolase transfers 2 carbons at a time. The ketose is the donor of the 2 carbons. The aldose is the acceptor. So if I donate 2 carbons of this 5-carbon sugar, I should end up with 3 carbons. If this 4-carbon sugar accepts 2 carbons, then it should end up with 6 carbons. So again, pause the video and draw the structures of the products of this reaction. Well, I didn't draw the structures of the products for you, but you should have noted that you would have a 3-carbon sugar, and since this was the ketose, you would get a 3-carbon aldose, and that of course is glyceraldehyde 3-phosphate. And if you had a 4-carbon sugar that accepted 2, you'd end up with 6 carbons. And if this is an aldose, then that becomes a ketose. And a 6-carbon ketose would of course be fructose 6-phosphate. So in summary, for stage 3, we started out with 2 molecules of xylulose 5-phosphate and 1 molecule of ribose 5-phosphate. Remember that these were the products of stage 2 of the non-oxidative branch of the pentose phosphate pathway. And what we've done in stage 3 is to carry out 3, and these are diagrammed down here, 3 carbon shuffling reactions to obtain 2 molecules of fructose 6-phosphate and 1 molecule of glyceraldehyde 3-phosphate. So if you've watched this video along with the others, hopefully this summary will make sense, where we started out with glucose 6-phosphate, and these 3 reactions right here show the 3 reactions involved in the oxidative branch, in which we obtained 2 molecules of NADPH. And then what we did is we took the ribulose 5-phosphate. We would have needed to carry this reaction out 3 times to get 3 molecules of ribulose 5-phosphate. In stage 2, we converted those 3 molecules of ribulose 5-phosphate to 2 molecules of xylulose 5-phosphate and 1 molecule of ribose 5-phosphate. And then in the carbon shuffling reactions in stage 3, we converted this to 2 molecules of fructose 6-phosphate and 1 molecule of glyceraldehyde 3-phosphate. And hopefully here that this reaction looks familiar, this pathway is familiar, that if you're following the arrows in this direction, you have glycolysis. If you're following the arrows in this direction, you have gluconeogenesis. So this provides a link from the pentose phosphate pathway to these 2 other pathways. Over here, the ribulose 5-phosphate is isomerized to ribose 5-phosphate, and that serves as a reactant in the de novo pathways of purine and pyrimidine biosynthesis, which of course are needed to produce the nucleotides for DNA and RNA. So this was the pathway that was shown to you at the beginning of the presentation. So maybe now this makes a little bit of sense. These arrows right here, 3 of them are drawn, again to show that we need to carry out the oxidative branch 3 times to get the ribulose 5-phosphate. We need to carry out this reaction twice to get 2 molecules of ribose 5-phosphate, once to get the ribose 5-phosphate, and then these 3 molecules then in the transketolase, transaldolase, and transketolase reaction will give us our products, 2 molecules of fructose 6-phosphate and 1 molecule of glyceraldehyde 3-phosphate. In the next series of videos, I will explain how we control the pentose phosphate pathway and balance the need for NADPH with the need for NADH, ATP, and other metabolites in the cell.